All right, hello there. So this is how a cow says hello. Anyway, so we're going to do section 4.7 today. It's pretty quick. And after the second example, you can basically stop the video if you want, or you can watch to make sure you know what you're doing. But anyway, this is almost like a continuation of what you did in section 4.7, where you're trying to go from like one world to another world. And if you watch the video from 3 blue, 1 brown, you're trying to have a point in a new world that's the same place as a point in the old world, or a vector, I should say. And so he gives some good visuals and whatnot. This is how to like make the matrix that changes it. So anyway, let's see. This top part up here is just kind of explaining it a little bit. Really what we're going with is this theorem right here. So B is a basis. So basically you have your basis vectors for your one world and your basis vectors for another world. And so, and then they tell you how to go between the two. And so you have this new kind of notation right here, this right here. So that notation right there is basically going to be the notation that tells you, or it's what it's going to be. It's going to be a matrix that changes a vector in B to C. So it changes B to C. It like moves it to the new world, or it gives you like the way that you would go to it in the new world versus the way you go to it in the old world. Okay? So if this part right here is talking about applying that matrix to something in the old world, and then what you do is you get a vector in the new world. Okay, so let's go ahead and you'll see it's very simple to do down here. I'll show you in the example there. All right, so there's two different ways that you might be given this information, and here's the first way down here. All right, so you have two bases, 1b, 1c, and you have for your vector space, and you have b1 is defined as this. So what this is doing, this is the first basis vector in B. So this is the basis vector. And remember the basis vector, I know it's written out long ways, but it's basically a column, so 1, 4. And this is another basis vector. And so that one is 5, -3. All right, and so what you do, basically by giving you that information, they're giving you the change. Like what do you do to change something in B to something in C? So they've given you the information right there. That's your P, B to C. And so you just take those columns, 1, 4, and then 5, -3, and there's your change of basis matrix. Okay? All right, so now they've given me something here. They said find xc, so find the vector in the new world for this vector in the old world. So what they've given you is this. They've given you this part right here. This right here is xb. So it's basically the vector in the B world, like, oh, go 5 spaces, then 3 spaces. So to find xc, I'm going to do my P of B to C, the matrix that we just found over here in part A. I'm going to multiply that by this vector that's in basis B already, and it's going to produce xc. It's going to produce the vector in the C world. So I'm going to take my 1, 4, 5, -3, multiply it by this 5, 3 that they gave me, and that gives me, if I do the multiplication, I get 20 and 11. All right, so what this is, I'll write it over here. This is the position of x, this x we keep talking about, the vector, in the C world. All right, which gets you to the same geographic, so the same like location, the same geographic spot as 5, 3 would in the B world. So these are just directions to go to the same spot depending on the world that you're in, okay? If you understand that kind of pedestrian phrasing of it. Anyway, all right, so how do you go back and forth between the worlds? And so this next part, you already know how to find this. All right, and if you want to get, like, let's say you're in C world, you're like, oh no, how do I get back to B world? So you basically do this. You do the inverse of that matrix and it'll change you back to the other world, okay? So we're going to do that right here. And basically the way to do that, like, so what you're usually given is you're given like the more regular way of being given things is you're given the basis vectors for the world, like there's B world and there's C world. So an easy way to find this initial thing to go from B to C is to set it up like this. And that's what all this information is like telling you right here. So what you're going to do to find your matrix that changes it from B to C is this. You're going to take your C vectors, so 1, 4, 1, 1, dot, 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 dot here, and then your B ones. So it's going to go in the same order that you have in the rule right here. You have B and then C. And then your B ones are -1, 8 and 1, -5. And what you're going to try to do is you're going to row reduce C. You're going to do work on this so that you basically get it in reduced row echelon form. So you basically get the identity matrix over here. Okay. All right, so here we go. I'm going to do first thing, -4 times row 1 plus row 2. And so that ends up getting me, the top row is staying the same, -1, 1. Let's see, and then so that would produce a 0 here. And then -4 plus 1, so I get -3. Then I get 12 and -9 here. All right, so then I'm going to divide the bottom row by -3. Okay, so that gets me to the top is the same. So 1, 1, -1, 1. So 0, 1, -4, 3. All right, and as a last step, I'm going to do row 1 minus row 2. All right, so then I'm done. I get 1, 0, 3, -2, 0, 1, -4, 3. All right, and so what you'll end up right here is this. You'll end up with, that's your P from B to C. It's the matrix that changes something in B to be its new location in C. All right, so I have that here. I have 3, -2, -4, 3. All right, and remember, this changes something in B world to C world, okay? So if you want to go backwards from C world to B world, right here, then all you have to do is find the inverse of the matrix that we already found. So to do that, this is just a 2 by 2 matrix, so why don't we just do the 1 over the determinant? Remember, you do 1 over the determinant, and then you switch these two, so you have D then A, and then you make the other two negative, so -B and -C. So if I do that here, so 1 over, my determinant would be 9 minus 8, so that'd be 1. All right, if I switch these 3's right here, you're not going to notice, so whatever. All right, so 3 and 3, and then these two right here, I have to make these negative right there. So those become 2 and 4. So multiplying these all by 1 gives me 3, 2, 4, 3. So this is the matrix I would use to change something in C world back to B world. All right, I wrote that a little bit large, sorry. Okay, all right, and so the next example, you can skip ahead, stop right now if you want, if you understand everything. I mean, that's basically it. I'm just going to show you, you can do this on your calculator. There's your homework down here. This right here is just like a little summary of that rule that I just talked about. But anyway, let's do example 3. So in example 3, if I want to find P from B to C, I would basically put these in here. I'd put C here, then B there. So C was 4, 1, and 5, 2. All right, then I got 7, -2, and 2, -1. And you can RF this in your calculator. Okay, so enter, the dotted line, you're going to know where that is, but you can just put in a 2x4 matrix. And when you RF it in your calculator, you get 1, 0, 0, 1 right here. The calculator doesn't know the difference. And there is your P of B to C right there. So 8, 3, -5, -2. All right, and then my determinant, to do my inverse, I get -16 plus 15, so that's 1 over -1. And then if I switch things around, -2, 8, make these negative, -3, 5. So my P of C to B is 2, 3, -5, -8. And